Water is a vital component of life. It is one of the most significant substances and serves a range of uses. Water is required for human survival, and it is used for cooking, bathing, washing, drinking, and other domestic purposes. But how does water get into our house? It is mainly because of the water distribution system. A water distribution system is one in which the drinking water is transported from the centralized treatment plant or well supplies to the service connection or consumer stops. Basically, these systems consist of a network of pipes, pumps, valves, storage tanks, reservoir, and other components. The purpose of the distribution system is to deliver water to consumers with appropriate quality, quantity, and pressure. However, as the social economy develops, providing water to all families, particularly in Pulilan, Bulacan, has become increasingly problematic. Given that several households still have no access to Nawasa due to its unavailability to their areas and only use of electric water tanks as a source of water. With this scenario, when power goes out, systems may not function fully, leading to no use of water at all. Oh no! It is a big problem! What are we going to do? In order to solve this problem, our objective is to design an efficient water distribution system that will connect the 15 pumping stations in Pulilan, Bulacan with a network of pipelines to ensure that the total branch length is minimized. We can only do this with the help of graph theory. The pumping stations in Pulilan are referred to as the vertices, while the pipelines that connect those pumping stations can be considered as edges of the graph. Where areas, the length of each pipe is regarded as the weights of the edges. As we can see, Pulilan has 15 water pumping stations and 28 pipelines connecting those stations. In this case, Kruskal's algorithm will be used to generate a minimum spanning tree, which involves using the pipelines to reach all the pumping stations of the network in such a fashion that the total length of all the pipelines is minimized. And that will solve the problem of the water supply network in laying pipelines successfully. But how will we know which route to use for the pipelines? Well, this is where we should use the concept of Kruskal's algorithm. First, we must arrange the edges from smallest to highest. Sorting out gives us the result in the table. Then, we will get the first 14 edges in the table to connect all the 15 vertices. We will take the edge with the lowest weight and add it to the spanning tree. If adding the edge created a cycle, then we will skip and reject this edge. Lastly, we will keep adding edges until we reach all the vertices. Since the first 12 edges with the lowest weight, which are edges BC, HI, IK, DE, KO, JK, CD, DO, FJ, GH, LN, and AE did not form any cycle, we will include them in the spanning tree. Next is the edge HJ. Since it creates a cycle, we will skip and disregard it. Even though it has the lowest weight, we will not include it in the spanning tree. The next with the lowest weight is edge MN. Since it didn't form any cycle, therefore, we will take and add it to the spanning tree. Since the edges CE, GJ, and JO create a cycle, hence we will reject and not include them. Lastly, since the edge KL did not form a cycle, that completes our minimal spanning tree. After several trials, the perfect water supply network route in Pulilan has been done. The edges that have the shortest path that connect all the pumping stations in Pulilan, Bulacan are BC, HI, IK, DE, KO, JK, CD, DO, FJ, GH, LN, AE, MN, and KL. The 14 pipelines connect the 15 pumping stations with the help of Kruskal's algorithm that aims to reduce the edges and its weights to generate a minimal spanning tree. The obtained minimum connection reduced the total length between pipelines from 92.5 kilometers to 31.2 kilometers. The water distribution system proposed is intended to be strong, efficient, and durable so it can serve the needs of the community in Pulilan, Bulacan in terms of quantity and quality water. The result from this study shows a combined total length of 31.2 kilometers of pipe is required to connect the main line in 15 settlements. The example analysis verifies the practicality and economy of the minimum spanning tree, and the Kruskal's algorithm has some guidance for the evaluation budget of project investment for the water supply system. Minimum spanning tree and Kruskal's algorithm not only applies to the water supply network, it is also used in real-life problems such as in laying cables and wires, and so on. The optimal routing paths can be calculated by using these algorithms to minimize the cost, to save time, save material, and save labor.